Today we will discuss on testing of hypothesis. A very important aspect of the sampling theory is the study of the test of significance, which enable us to decide on the basis of the sample results if 1. The deviation between the observed sample statistic and the hypothetical parameter value. 2. The deviation between two independent sample statistics is significant or might be attributed to chance or the fluctuations of sampling. For testing a hypothesis, we want some important points related to that. First is null hypothesis. Null hypothesis is a definite statement about the population parameter and it is usually denoted by H0. It is usually a hypothesis of no difference. Second point is alternative hypothesis. Any hypothesis which is complementary to the null hypothesis is called alternative hypothesis, usually denoted by H1. For example, if we want to test the null hypothesis that the population has a specified mean mu0, then the null hypothesis is H0 such that mu is equal to mu0. Then the alternative hypothesis could be H1 such that mu is not equal to mu0, that is mu may be greater than mu0 or mu may be less than mu0. We call this as two-tailed alternative. And other alternative hypotheses are H1 such that mu greater than mu0, we call it right-tailed alternative. And third is H1 such that mu less than mu0, it is left-tailed alternative. Reject H0 when it is true, that is known as type 1 error. Type 2 error, accept H0 when it is wrong. Then the size of the type 1 error or probability of type 1 is also known as alpha, the size of the type 1 error. Also it is denoted by alpha. Also probability of type 2 error or denoted by beta. In practice, type 1 error amounts to rejecting a lot when it is good and type 2 error amounts accepting a lot when it is false. Another point is critical region. In a critical region in the sample space which amounts to rejection of H0 is termed as critical region. In two-tailed test, critical region comes in two sides of the sampling distribution, and one-tailed test either it may be in the left side or in the right side. Next is level of significance. The probability that a random value of the statistics belongs to the critical region is known as the level of significance. Or in other words, we call it as size of the type 1 error. Usually 5% and 1% are employed in testing a hypothesis. The level of significance is fixed in advance before collecting the sample information. Then one-tailed and two-tailed test. In any test, the critical region is represented by a portion of the area under the probability curve of the sampling distribution of the test statistic. A test of any statistical hypothesis where the alternative hypothesis is one-tailed is called one-tailed test. In one-tailed means it may be either right-tailed or left-tailed. In the right-tailed test, the alternative is H1 such that mu greater than mu0. The critical region lies entirely in the right tail of the sampling distribution. In the left-tailed test, H1 such that mu less than mu0. The critical region lies entirely in the left tail of the distribution. In two-tailed test, H1 such that mu is not equal to mu0. The critical region lies in the both tails of the probability curve of the test statistics. Then another important point is critical values or significant values, because it determines whether the hypothesis is rejected or accepted. The value of the test statistic which separates the critical region and acceptance region is called the critical value. It depends on the level of significance and the alternative hypothesis, that is whether it is two-tailed or single-tailed. For large sample tests, that means the sample size is 30 or more than 30, the normal distribution of the sampling distribution, and the letter result is used to represent the critical value. In doing the problem, we have to check whether the sample size is greater than or equal to 30 or less than 30. In sample size is greater than 30, we always use this value for 1% and 5%. For two-tailed test, the level of significance is 1%, the critical value is 2.58, and 5% it is 1.96. And for one-tailed test, either it may be left-tailed or right-tailed, 1% is value is 2.33 and 5% 1.645. For doing problem, these two values are essential for doing the problem, either 1% or 5%. Other percentages are available in the tables. For other sampling distribution like t distribution, chi-square distribution, f distribution, we get the critical values or significant values from the statistical tables. Then how to do a conducted test or procedure for testing your hypothesis. In any test, depends on the problem, we have to first of all set up the null hypothesis H0. That means in this case we say that there is no difference between the values. Second, set up the alternative hypothesis H1. In this case, there are three cases may depends on the problem. It is two-tailed or left-tailed or right-tailed. 3. Choose the level of significance alpha. Usually we will take it as 1% or 5%. Compute the test statistic Z, T and F. Statistic simply means it is a function of the sample values. Okay, a formula connected with the function of the sample or a function with the sample values, simply call it as a statistic. For each problem, the statistic differs from problem to problem. Then how to take the conclusion? With the calculated value of modulus Z, we always take the absolute value. Absolute value means whether positive or negative, we always take it as positive. If the calculated value of Z, modulus value, less than the significant value, we accept the hypothesis. And if it is more than the tabled value, we reject the hypothesis. Okay, these are the procedure for testing of hypothesis. Another approach related for is p-value approach. The p-value is another approach to test null hypothesis about the population mean based on a large sample. The p-value measures the strength of the evidence against the null hypothesis. That is, p-value indicates the actual risk of committing type 1 error when the null hypothesis is rejected based on the observed value of the test statistic. The smaller the p-value, the more evidence there is against the null hypothesis H0. A small value indicates the value of the test statistic is unusual given the assumption that the null hypothesis is true. In practical, we take a p-value less than or equal to alpha, the level of significance, we reject H0, and the p-value greater than alpha, we accept H0. In the second part, we discuss how to do the problems in the topic testing your hypothesis.